Hi, I'm Göksu, and today I'm going to talk about rotational motion, angular speed, angular acceleration, moment of inertia, and a little bit torque. And we're going to do experiment and discuss the results of the experiments. But before we start, I'm going to introduce some concepts, then you can be familiar with the topic, okay? First of all, we're all familiar with Newton's second law, which is F equals to ma, right? And mass in that formula actually is similar with the moment of inertia. Mass can be described as resistivity against linear motion, right? And moment of inertia also described as resistivity against rotational motion. But moment of inertia does not only depend on mass, it also depends on rotational axis, the mass, and the shape of the object or the type of the objects. So many things. Let me just quickly talk about the experimental setup. I have Airtable, pack, pulley, and rope. I stick the pulley into the Airtable and I use the rope to make the connection between the pulley and the pack. I leave the pack to slide down, move forward, and as it slides down with constant acceleration, it makes pulley to rotate with constant acceleration. Then at the same time, I compress the sparker to get some points. Then I measure this points, the displacement, and then the time. Then I draw some diagram to calculate the acceleration by using the slope. So let me just show you the experiment. I have real acceleration value, which I can find from this equation. And also I have an acceleration value that I find from the graph. My error is 14%. I think it's okay, not a big deal. Now I want to discuss what can we find from what we know, okay? We know distance, we know time, we know mass, we know the radius of the pulley and the packs. So we can find linear and angular acceleration and velocity. And also we can discuss energy conservation, okay? First of all, their kinetic energies are different because pulley rotates, but packs moves forward without rotating. So pulley has only angular kinetic energy, which can be calculated by using the formula 1/2 I, which is the moment of inertia, omega square. Moment of inertia of the pulley can be calculated by using the mass and the radius, right? And the pack's kinetic energy can be calculated by using 1/2 mv square, which we know all of them. So the total kinetic energy is the sum of their kinetic energies. Then we can look at their potential energies. Their potential energy actually can be calculated by using the mgh. We all know we know all of the values. H is equal to the H of the Airtable. So we can just sum of their potential energy and look at are they the same or not. For sure they are not same because of the friction of the sheet of paper. So there is not energy conservation. That is all.